Largely, interview was a bit challenging towards the end because there were specific, very narrow questions which I did not know. But apart from that, I don't know. Initially, it started off okay, started off a bit unconventionally. Even this, like, I think from the interview transcript, you can see that there's no, like, nothing will completely prepare you for what the interview will be like, right? Like, in my interview, normally they start with questions like, oh, why do you want to join civil services? Why IAS? Something like that. Like, here he started by asking about leather industry, about textile industry, which is a bit unexpected. So I think, like, I guess learning from this is that you need to keep revising, you need to keep learning, you need to learn about a broad spectrum of areas in order to do well in an exam like UPSC. Okay, so interview overall, whatever marks come, we won't know until end of September. So now our job is to prepare for prelims, to continue to prepare for prelims, because October 10th is like very, very nearby. Here's what I had in mind initially to start with, that I was thinking we will try and do geography this week and couple of concepts from current affairs. Okay, so in geography, what we will look at is I was thinking we will look at landforms, processes of making landforms, as well as origin of the earth. Fine. And tomorrow, maybe we can start looking at climate. Tomorrow we'll try and look at climate, because climate, I believe, is an area that every single year UPSC has asked questions. One way or the other, climate, some questions have come, and it's a very conceptual area that if we do this, if we revise also decently, we'll be able to answer questions. So climate tomorrow, at least my focus will be on revising the basic concepts first, and then doing a lot of questions. Climate, I've collected a lot of questions, and later on, let's see how it goes, where it goes. Maybe a couple of current affairs. Okay, let's start from the basics, right? Let's start with what are the sources for geography, just to make sure you're all on the same page. Okay. So geography for me, there are two sources that I use primarily. First is the NCRT class 11 and class 12. NCRT class 11 is physical geography. NCRT class 12 is human geography. So these two books are both are fundamental. They're very easy to read, and doing these will give you enough of a foundation to solve UPSC questions. Second book that I used was GC Leong. GC Leong I used for climate-based concepts, climatic regions, human geography in climatic regions. These are all covered very nicely in GC Leong. And for landforms, that along with different landforms associated with rivers, with ice, with islands, these are all not covered in NCRT. So these areas which are not covered in NCRT, you need to cover in GC Leong. You're right. Like, climate in NCRT chapter is a bit not only boring, but also not directly tied with the kind of questions which UPSC is asking. So climate is something that needs to be covered from GC Leong. What I'll do tomorrow is, for climate, I prepared a summary of my own. Let's start with just the structure of the Earth, how Earth was formed. We can go section by section and look at what are the important concepts from which UPSC has asked questions in the past and which you need to revise from a factual standpoint. So we'll do that, and along with that, I'll maybe try and focus also on some important areas in geography which have been in the news. Because UPSC loves asking geography questions. UPSC loves asking questions like, for example, Mazar-e-Sharif is where Taliban this year first managed to strike and retain control. Okay, so something like that. We can try and look at where these areas are, what these areas are, how they're important. Okay, wait, let me see. Has the audio improved? So today, so today let's start with geography, and I'll keep it simple. I'll keep it very simple for today, and we'll do like a quick revision of some of the very basic concepts from geography, and then I'll try and add to these things as time goes. Fine. So first thing, let's look at some important terms from the initial chapters from geography, right? So you need to remember that there are certain names and certain scientists geographers who have given hypotheses and theories. So nebular hypothesis, you need to know that Laplace has given. Laplace, a mathematician, gave nebular hypothesis. Nebular hypothesis, what is the basis? Nebular hypothesis basis is that material, all the material, gas, dust, everything was formed around the sun and existed as a large nebula. All these concepts I hope you've covered in geography. This is just a quick revision so that you immediately remember when you're doing questions, when you're doing and practicing for prelims. So nebular hypothesis, that sun is surrounded by a solar nebula. Solar nebula has gases as well as dust. And through the process of accretion, accretion is an important term here, accretion. ACCRETION. Through the process of accretion, we led to the formation of sun as well as the planets. Okay. Next important theory is obviously Big Bang. Okay. Solar nebula theory. Like I hope you've all, nebula theory was given by Laplace. Nebular theory was given by Laplace. Okay. Next one is Big Bang theory. Next one is Big Bang theory. Big Bang theory is given by Hubble. Big Bang theory is given by Hubble. Okay. It's also known as the expanding universe theory. Big Bang theory, also known as expanding universe theory. Big Bang theory by Hubble, also known as expanding universe theory. So Big Bang theory, what happens? Big Bang theory says that all the matter in the world, in the universe itself, all the matter that has ever existed in the universe was concentrated at one point, known as a singularity. From that singularity, through a Big Bang, there was expansion of the universe and energy was converted into matter. Energy was converted into matter. Okay. This is the Big Bang theory, and according to this theory, the important fact you need to remember for prelims, is universe is still expanding. Universe is still expanding. Based on this concept, UPSC has asked a question in the past as well. Past 10 years questions, if you go through in geography, UPSC has asked a question on Big Bang theory. Question was basically on, is the universe still expanding or no? And currently universe is still expanding. Okay. So universe is still expanding. However, the planets themselves are not expanding. Distance between planets is not expanding, but universe is expanding. Okay. So for prelims, just remember this concept. Universe is expanding, but planets themselves are not expanding. Then next section, which so these are the two large important theories which with respect to the solar system and formation of the universe. Okay. The next section which is important is the types of planets and differences between them. Types of planets and the differences between them. So you have 8 planets in total. You have 8 planets in total, out of which 4 are terrestrial and 4 are gaseous. 4 are terrestrial, 4 are gaseous. You're all aware that Mercury, Venus, Earth, Mars are terrestrial. Jupiter, Saturn, Uranus, Neptune are gaseous. So why is here there are 3 facts which you need to remember, which I'm going to revise for you, which are, why are the first 4 planets terrestrial? There are 3 facts for this which you need to remember. Why the first 4 planets are terrestrial? And the last four planets are gaseous. There are three facts to remember. First is that for the first four planets, they are so close to the sun that gas cannot condense. It stays as gas only. First four planets, so close to the sun, gas cannot condense, stays as gas only because of the heat. Second reason is solar wind. From the sun, you have solar wind, meaning solar particles, solar plasma. All these particles will, like the Earth and all the other terrestrial planets, will be bombarded by these particles, due to which the gases escape. The gases escape. Third fact to remember is that terrestrial planets are much smaller than the gaseous planets. So the force of gravity for terrestrial planets is smaller. And because force of gravity is smaller, they cannot retain the gases. Three facts for why first four planets are terrestrial, last four planets are gaseous. First is that it is too close to the sun, so there is heating effect. Heating effect meaning it is maintained only as gas. Due to heating effect of the sun, maintained as gas. Second is because of solar wind. Solar wind leads to gases escaping from the atmosphere. Solar wind leads to gases escaping. And third reason is because the planets themselves are smaller. Because the planets are smaller, it means that they do not have gravitational force to retain the gas. So what is left? Instead, you have a rocky terrain. In the gaseous planets, in the Jupiter-like planets, also known as Jovian term. Jovian meaning Jupiter-like. Jovian planets, they are made up of gas. They do not have land. They are made up of gas. Okay, let's move on to the next part, which is origin of the moon. Origin of the moon, you need to know that there is a theory known as Big Splat theory. Origin of the moon, there is a theory known as Big Splat theory. According to Big Splat theory, the moon was once part of the earth, and due to a collision, it broke away. For origin of the moon, you need to know that there is a theory known as Big Splat theory. According to Big Splat theory, due to an impact, the moon separated from the earth, and now it revolves around the earth. Okay. Now, related to the moon thing, you need to know there's one very important fact which will come later also. Okay. And these facts, again, the reason I'm focusing on these facts is that there's no logic to these facts. You only need to remember them. The more you keep revising these facts, the better they will stay. You will be able to remember them in your head. Okay. For example, like there is no logic as to why, and this, like, remember this fact. When the impact happened, when this big splat happened, it led to increased heating of the earth. When big splat happened, it led to increased heating of the earth. This is just a fact. Okay. This is just a fact. There is no logic to it. You just need to remember it as is. When big splat happened, when this impact happened, it led to increased heating of the earth. The impact of this heating of the earth, we will look at as I continue explaining. But for now, you need to remember that big splat led to heating of the earth. So this is just a fact that you need to remember, because UPSC can ask these statements. Like it can ask two statement questions. Like big splat led to increased heating of the earth. Moon is said to be part of was used to be part of the earth earlier before big splat theory, right? Then you need to answer that both statements are correct in such a scenario. So you need to remember both the concepts as well as such facts. Even though these facts may seem boring, they may not seem interesting. You may think like, what is the importance of this at all? You just need to remember it because it can be asked. Okay. So next section is the how the earth has come about to be formed. Let's revise this part also quickly. How the earth has evolved. Okay. So first is that there is something known as a primordial stage. So primordial meaning is initial. When the earth was formed, immediately after the formation of the earth, in the initial stage of formation of the earth, that is known as primordial stage. Initial phase of formation of earth is known as primordial stage. So what happened in primordial stage? We'll divide into two parts. First is changes in the earth's crust. Okay. meaning the ground. What are the changes that happened on the ground? Also known as the lithosphere. And second part is what are the changes that happened in the atmosphere from primordial stage to the earth that we have now. From the primordial stage to the earth that we have now, we are going to look at what are the changes that happened. Fine. First, let's look at the changes in the lithosphere. Lithosphere meaning the ground. Changes that happened in the ground. So first is that temperature and density increased on the ground. Okay. Temperature as well as density increased on the ground. So what happened with the increase in temperature and density? The Earth's crust, the entire Earth, started getting separated into different densities. The Earth started getting separated into different densities. Okay? The Earth started getting separated into different densities. And this is how we have core, mantle, crust. This division of structure of the Earth happened due to in the primordial stage, temperature as well as density started increasing. With increase in temperature, the earth started getting separated into different sections, into core, into mantle, into crust. And this process of separation into various components was accelerated due to the big splat. Big splat, temperature increased even further. Temperature increased even further, meaning densities also started getting separated faster. Fine. So this leads to one important logical conclusion. Okay, I'll repeat, but generally don't expect me to repeat this very often because we need to revise faster. If we go at a slow pace, we will not be able to revise everything before prelims. So focus needs to be on revising everything before prelims. Okay, just remember that. We are on a clock this time, right? You need to remember that there are 49 days left to prelims. 48 actually. Okay, fine. So there's increase in temperature, increase in density, which leads to separation into core, mantle, crust. And this process is accelerated by big splat because it leads to increase in temperature. So these are the concepts that you need to remember. Okay. One important conclusion as a result of this process is that density increases as we go deeper into the earth. Due to this process of evolution, density increases as we go deeper into the earth. From crust to mantle to core, density is constantly increasing. So second part is how has the atmosphere evolved. So in this there are three stages. There are three stages in which atmosphere has evolved. First is that all the hydrogen, helium, the primordial gases. Again, primordial meaning initial, ancient. That is the meaning of primordial. Primordial gases were taken away from the earth through the process of solar winds. Solar winds stripped away the atmosphere of the initial atmosphere of the earth. Second stage is known as degassing. Second stage is known as degassing. And when I'm saying these terms and putting emphasis on these terms, make sure you remember them. Okay? Because these terms are very important. Second stage is known as degassing. In degassing, what happened? Through volcanic eruption, water vapor was released from the interior of the earth. Water vapor is released from the interior of the earth in the second phase, known as degassing. Why is it known as degassing? Because gas is going from interior to the atmosphere. Okay. Which gas, and primarily what is the most important gas which is going here? Water vapor. Okay. Water vapor is what is allowing life to be possible on earth. Okay. So there's water vapor, there's nitrogen, there's lots of carbon dioxide, there's methane, and very, very little oxygen at this stage. At the second stage, there's water vapor, there's lots of carbon dioxide, there's nitrogen, there's ammonia, there's methane, but there's very little oxygen. And this process continues. This process continues for millions of years. Millions of years, this water vapor is coming in. Okay. Then there is cooling. There is cooling of the earth. Why is there cooling? Because now all the eruptions have stopped. Volcanic eruption kept happening. Earth became very hot. But volcanic eruption stopped after a point. As volcanic eruption stopped, Earth started cooling. When water vapor cools, what happens? There's rain. Okay. So it started raining in the earth. And as it started raining, rain led to even more cooling. Rain led to even more cooling. Okay. And this excessive rain is how the oceans were formed. This continuous rain for millions of years. There's cooling, there is more rain. There's more water vapors still there in the atmosphere, water vapors continuously condensing, more and more rain. Earth is cooling even further, even more condensation, even more rain. Okay. So this led to formation of the oceans. And the third stage is the production of oxygen. Third stage of evolution of Earth's atmosphere is production of oxygen. Okay. So in production of oxygen, what happens is first you have this photosynthesis taking place in the oceans, because life originated in the oceans, right? Life originated in the oceans through plants, and these plants started producing oxygen. As oxygen saturated in the oceans, oxygen also escaped into the atmosphere. Okay. Oxygen escaped into the atmosphere, and slowly the carbon dioxide of the earth was replaced with oxygen, which is why we have the current division, which is like oxygen is 21% of the earth and carbon dioxide is only like 0.1%. Okay. So this is the evolution of the earth. Fine. So all of these processes, to answer a doubt, all these processes happen continuously, one after the other, one after the other. Okay. So these concepts are clear. Fine. So one important fact again to remember for prelims, just have to mug it up. Okay. On the time scale, geological time scale, largest is eons. Then you have era. I'll type it out. On the geological time scale, you just need to remember this as a fact. Eons are greater than era, greater than period, greater than epoch, greater than age. Okay. This is the sequence. You have to remember it as a fact. Eon is greater than era, greater than period, greater than epoch, greater than age. Okay. Along with this, the important thing to remember is what is our current era, what is our current period, what is our current epoch. Okay. So our current epoch is known as Holocene. Holocene, but we're also considering like in terms of current era is known as Holocene, but we are also talking about a new era, start of a new era known as Anthropocene. Okay. So Anthropocene term is very important because Meghalaya, in the Anthropocene there is a term known as Meghalaya age. Okay. There's a term in Anthropocene known as Meghalaya age. Now, why is it called Anthropocene? Anthropocene because anthro means man. So man is the biggest factor influencing this geological period, this geological epoch. Okay. The current geological epoch is known as Anthropocene, transitioning from Holocene. We're transitioning from Holocene. In Anthropocene, there is an important term known as Meghalaya age. So if ever there's a question in prelims saying Meghalaya age is related to which field, it is related to geology. Okay. Meghalaya age is not related to history. It is related to geography and geology. Okay. It is epoch. Currently, it is epoch. The Anthropocene epoch. The period. What is the period that we're going through? The period is Quaternary. Okay. Quaternary period. The current period we are going through is known as Quaternary period. And the era is Calnozoic. And the era is Calnozoic. So currently we are living, like today in 2021, we are living in the Calnozoic era, in the Quaternary period, in the Anthropocene epoch, in fine. And age is like, again, transitionally, it's like, I think Meghalaya age is what is happening right now, but I'm not sure. Okay. But again, facts to remember are, you go from eon to era to period to epoch to age. Age is the smallest unit. Age is the smallest unit. Eon is the biggest unit of measuring time in geology. Okay. So let's move on to the next section. Next section is the interior of the earth. Okay. Next section is the interior of the earth. In interior of the earth, like, let's again go quickly, like quick summary. Fine. Direct sources. What are the direct sources for us to know about the earth? Direct sources are like interior of the earth, drilling into the interior of the earth itself, as well as studying of meteors. Studying of magma. Studying of magma as well as drilling into the earth. That is the direct way of learning about the earth. Okay. So if we drill into the earth 3 kilometer, 4 kilometer, we can understand what the interior of the earth is up to that phase. And sometimes from the interior of the earth itself, we have magma which is coming out. Okay. That magma tells us about the interior of the earth. This is the direct source. What are the indirect sources? Indirect sources are kind of more important. Why are indirect sources more important? Because directly we cannot drill into the earth that much also. Drilling into the earth is very expensive, very hard, and very hot. So we rely mostly on indirect sources to understand about the earth. So what are the indirect sources? First indirect source is meteors. First indirect source is meteors. Why? Because meteors also have similar structure to the earth. Meteors help us understand what the earth must have been like ages ago. Okay, meteor spelling I'll just send. Okay, studying of meteors, studying of comets. These help us tell us about the evolution of the earth. So this is one indirect source. Second indirect source is by studying of gravity, magnetic field, and seismic activity. Second indirect source is studying of gravity, of magnetism, of seismic activity. How seismic activity? It is through this studying of earthquakes. Okay. Magnetic activity, because different layers of the earth have different magnetic properties. Okay. So briefly, I'll tell you that because, for example, the core of the earth is made up of nickel and iron, nickel as well as iron. So that will have magnetic property. But crust of the earth will have less magnetic property. Okay. Magnetic property will also change based on different parts of the crust. So by studying these also, we can try and understand what the earth is like. Okay. Again, this part is not important, so we'll not spend a lot of time on it. This is just, okay, briefly, there are direct sources to study earth. There are indirect sources to study earth. Okay. Now, in seismic activity, there is a very, very important area. Extremely important. Consistently questions have been asked based on what are body waves, what are surface waves, what are P waves, what are S waves. Okay. The concepts are very important. Okay. What are S waves, what are P waves, what are body waves, what are surface waves. Okay. So, first thing, let's look at differences between P waves and S waves. Let's look at the differences between P waves and S waves. Okay. First thing, both P waves and as well as S waves are body waves. Okay. Both P waves as well as S waves are body waves. What does body wave mean? Body wave means it is produced at the focus. Both P waves as well as S waves are body waves. Body wave means it is produced at the focus of the earthquake. Okay. So now let's look at the differences. First is that P wave is a longitudinal wave. P wave is a longitudinal wave. P wave is a longitudinal wave. S wave is a transverse wave. P wave is a longitudinal wave. S wave is a transverse wave. Okay. So P waves vibrate parallel to the direction of the wave. P waves vibrate parallel to the direction of the wave. P waves vibrate parallel to the direction of the wave. And they are longitudinal waves. S waves vibrate perpendicular. S waves vibrate perpendicular to the direction of the waves. Okay. P waves arrive first. P waves are faster. P waves are faster. And therefore S waves are slower. Okay. P waves are faster, S waves are slower. P waves travel through gas, liquid, and solid, all three. P waves travel through gas, liquid, as well as solid. S waves travel only through solid. S waves travel only through solids. So these are the and shadow zone. Last difference is shadow zone. Shadow zone for S waves. Shadow zone for S waves is entire region beyond 105 degrees. For S waves is entire region beyond 105 degrees. For P waves, it is between 105 to 145 degrees. The shadow zone for P waves is 105 to 145 degrees. For S waves, it is 105 degrees onwards. Okay. So then what is the shadow zone? Shadow zone is when an earthquake occurs. When an earthquake occurs, there are certain regions of the earth where P waves and S waves are not received. Okay. These regions are known as the shadow zones. So supposing earthquake happens in a certain part of the earth, okay, at an angle beyond 105 degrees, S waves cannot be found. And between angle 105 to 145 degrees, P waves cannot be found. These are known as shadow zones. Okay. For anyone who does not understand this concept completely, I would recommend watching some YouTube video. We cannot explain the entire concept because, again, like we need to complete the syllabus, at least revision in a faster way. Okay. So these are the differences between P waves as well as S waves. Okay. P waves are longitudinal, S waves are transverse. P waves, solid, liquid, gas. S waves, only solids. P waves vibrate parallel to the direction of the wave. Like particles will vibrate parallel to the direction of the wave. In S wave, the matter will vibrate perpendicular to the direction of the wave. Okay. So this is an important area, and P waves are faster. Fine. Division done. P waves versus S waves. Okay. Now let's also look at some important terms related to earthquakes. Let's revise some important terms related to earthquakes. Okay. So first is known as focus or hypocenter. Focus or hypocenter is the point where the earthquake is taking place. Focus or hypocenter is the point where the earthquake is happening. Point where earthquake is happening is known as focus or hypocenter. The point where the energy The earthquake impact is there on the surface of the earth, exactly above the hypocenter. The point exactly above the hypocenter, where the impact of the earthquake is felt first, is known as epicenter. So between these two terms, the differences you need to be clear. Okay. Epicenter is on the surface. Hypocenter is inside the earth. Hypocenter is also known as focus. Hypocenter is also known as focus. It is inside the earth. Epicenter is on the surface of the earth. Epicenter is on the surface of the earth. Hypocenter is inside the earth. Okay. And epicenter characteristic is it's the first place to experience the earthquake. Epicenter becomes the first place to experience the earthquake. Epicenter becomes the first place to experience the earthquake. Okay. Next term related to this section is the surface waves. Okay. So when these body waves, P and S body waves, reach the surface, body waves are inside the surface of the earth, P and S waves. When the P and S waves reach the surface of the earth, they cause surface waves. Okay. And these surface waves are the most destructive part of the earthquake. Okay. The body waves interact with the surface to cause surface waves, and surface waves are the most destructive part of the earth. Okay. Fine. Earthquakes can be caused due to volcanoes. They can be caused due to seismic activity, tectonic activity. They can be caused due to large hydro projects, in which case they are known as reservoir-induced earthquakes. And they can be caused due to mining accidents. Okay. These are all the various ways in which earthquakes can be caused. Fine. Next, some other important terms which you need to understand are soil liquefaction. Soil liquefaction. Soil liquefaction, spelling I'm just sending once. Soil liquefaction. In soil liquefaction, what happens is when there is excessive water in the soil. In soil liquefaction, when there is excessive water in the soil, then that soil starts behaving like a liquid. This concept is known as soil liquefaction. In the soil, if there is excessive liquid, the soil itself starts behaving like a liquid. Then this is known as soil liquefaction. What is the downside of soil liquefaction? It can lead to disasters. Okay, because soil is no longer stable. If there's lots of water in the soil is no longer stable. Buildings can start collapsing. Okay, so this is soil liquefaction. Another concept is differential ground settlement. Another concept is differential ground settlement. Differential ground settlement. Differential ground settlement. In differential ground settlement, the soil starts moving down a slope, leading to buildings becoming crooked. in differential ground settlement, soil starts moving down the slope, leading to buildings becoming crooked. Soil starts moving down the slope, leading to buildings becoming crooked. Okay. So next section we look at tomorrow onwards is we look at the structure of the earth and what the various discontinuities are. Actually, I'll just share that diagram with you right now. No, so difference between differential soil settlement and landslide is that landslide is a rapid process. Landslide is a rapid process. Differential ground settlement is a slow process. Okay. Landslide is a rapid process. Differential ground settlement is a slow process. Landslide is a rapid process and differential ground settlement is a slow process. Let me try and share this image with you once. Yeah, this is similar to soil creep. Oh, I'm not able to share images. Okay, fine. So basically, okay, I'll try and share the link then. Okay. Yeah, so I sent the link for the image. So this is structure of the earth. And in this for prelims, what you need to remember, the factual information you need to remember for prelims is what are the various discontinuities. What are the various discontinuities? Conrad between upper and lower crust, Mohorovich between lower crust and upper man. This diagram is not there in the NCRT. Okay, this diagram is not there in the NCRT, but it's very important. Fine. Repetti between upper and lower mantle, Gutenberg between lower mantle and outer core. This you need to remember. Fine. So yeah, just make sure that those details you remember. Tomorrow we will we'll try and do the rest of geography. We'll keep doing geography. We'll keep trying to complete. Oh, it's not opening. Okay, wait 1 second. Okay, let me. Is it opening or not opening? Okay, wait 1 second. Oh, it's opening, right? Fine. Okay. Yeah, okay, fine. So that is the diagram for all the various discontinuities. This diagram is important because it is not there in the NCRT. But questions have been asked on this in the past. In the past, they have asked questions on like Conrad discontinuities between which and which. Okay. So those you need to be able to look at and answer properly. So before we conclude today's class, I just wanted to ask, is this okay for all of you? The pace, the concept, everything, okay? Because what I'll be doing is I'll try and revise as much of this as possible. And tomorrow, what I'll try tomorrow we'll focus on trying to do many more questions related to these concepts. Okay. So no, I'll try and finish geography. I'll try and finish physical geography, and then we will try and do polity. Okay. And if you're able to keep up with this pace, then I'll try and go even faster. I'll try and go even faster because my idea is that within the week we need to complete geography. We need to complete geography, including questions. Okay, including the questions. So fine. So tomorrow let's meet again. Tomorrow I'll try and talk to CSB about the time, and I'll tell you what time we can settle on. Okay. So thanks everyone, and we'll meet again tomorrow. And just so you know, tomorrow we will try and complete at least the earth, interior of the earth, maybe some of landforms, so that we can move on to climate. Climate is extremely important. Okay, climate for geography, every single year there are questions.